Section 710 is called inverse trigonometric functions. And we've talked about inverse before, but now of course we're talking about it with regards to trigonometry. So a couple things just to recall about inverse functions. One is that we switch the input and output values. Another is that they cancel each other out. So for example, f of the inverse of f of x cancel. And similarly, the inverse evaluated at f of x also cancels. When I say cancel, it's almost like these functions don't even exist, because if you input x, if you input x to the inverse, the function evaluated at the inverse function of x just gives you x back. So let's talk about how this relates to trigonometry. We've talked about the unit circle a lot. And it's called a unit circle because the radius is 1 unit. So that means we have a point here at 1, 0. We have a point here at 0, 1. Here it's negative 1, 0. Here the value is 0, negative 1. In degrees, this is 0 degrees, or 360. This is 90 degrees. This is 180 degrees. This is 270 degrees. In radians, this would be 0 radians, or a full circle is 2 pi. This would be 180 degrees, we said was just pi radians. If you take that and divide it by 2, you get 90 degrees. And then 270 is 3 pi over 2. We also know that the x value of any of those points along the circumference represents the cosine of theta. Y, it represents the sine of theta, assuming the radius is 1. And then y divided by x is called the slope, which would also be the tangent of theta. So if I told you that the cosine of pi over 2 is 0, what we could do is we could also write that using inverse trig. So we're inputting an angle and getting out a value. Using inverse trig, what we could say is what cosine, or cosine of what angle, gives us 0? And the answer would be pi over 2. One thing to keep in mind when we're talking about inverse cosine is that it will only give us values between 0 and pi radians. So whenever we are doing problems that involve inverse cosine, we have to keep in mind the calculator is going to give us values between 0 and pi. Next, let's take a look at the sine. If I asked you what's the sine of pi over 2, we go to pi over 2 as the angle, and it would tell us that the value there, the y value, is 1. We could write this using inverse trig, and this just means the sine of what angle gives us 1, and of course the answer is pi over 2. You could even type this into your calculator, making sure that you are in radian mode, and we hit the inverse sine of 1. and the calculator says it's 1.57. 1.57 is the same thing as pi divided by 2. Pi being 3.1418, and if we divide that by 2, we get 1.57. One thing to keep in mind with inverse sine is that inverse sine is defined from negative pi over 2 to pi over 2. So when we go to get an answer, inverse sine is going to give us a value from here to here. Inverse cosine is going to give us a value from here to here. And then lastly, we have the tangent of pi over 2. Tangent of pi over 2, remember, would be y over the x value, so this would just be undefined. Let's do one where we actually get a value, like if we were to take the tangent of pi radians. The tangent of pi radians would be 0 over negative 1, or just 0, which then tells us that the inverse tangent of 0, so tangent of what angle gives us 0, the answer is pi radians. Alright, so one thing to keep in mind with tangent is only defined from negative pi over 2 to pi over 2. Okay, so with that said, even though tangent, what angle gives us a tangent of 0, even though that's correct at pi, tangent inverse is only defined from negative pi over 2 to pi over 2. So we need another angle that gives us 0 for tangent, and that would also happen at 0 radians. 0 radians is a better answer because it's between negative pi over 2 and pi over 2. So this is going to come back for the problems that we work on, but let's just highlight this for now. And one thing to keep in mind is that when we're working with inverse trig, we input the angle and we output a value. So I'll just write that over here. So regular trig and then inverse trig. All right, with regular trig, the input is an angle and the output is a value. For inverse trig, the input is the value and the output is the angle that gives you that value. So let's take this and let's apply it to our investigation problems. This first problem, determine the angle, measure in radians indicated in the diagram. So we're actually going to do this 3 different ways. One way we'll do it is by using sine. Another way we'll do it is by using cosine. And then the last way we'll do it is by using tangent. And then you could figure out which way is easier for you to do. So first thing is we know that the sine of an angle is the y value, right? So for this problem, we have that the sine of theta would equal negative 3.484. And remember, the radius is 6, so we have to multiply the angle by 6 in order to get negative 3.484. If we want to figure out what theta is, what we could do is divide both sides by 6. And then we could go ahead and take the inverse sine to get the angle by itself. And this tells us that the angle, let me type this in here, so the inverse sine in radian mode is negative 3.484 divided by 6. And this comes out to negative 0.6195. Alright, so this isn't the final answer, because remember that sine is defined from negative pi over 2 to pi over 2. And what it's telling us is it's giving us an answer between there, and that would be this angle. So this angle right here is negative 0.695. And that's just what this one is. So this is 0.6195. That's called a reference angle. Because that's what that angle is, that means that this angle is 0.6195. And the whole angle would be pi radians plus 0.6195. And that comes out to be, so I'm going to do 0.6195 plus pi, and that equals 3.7611. That would be our angle. So it gets a little bit confusing. The reason why it's confusing is because inverse sine only gives us an angle between negative pi over 2 and pi over 2. So we have to consider that, look at what angle it's giving us, and then apply that to the bigger angle. So let's do the same thing with cosine. We know that 6 times the cosine of theta is equal to negative 4.885. If we divide by 6, we get the cosine of theta is equal to negative 4.885 over 6. And then to figure out the angle, we take the inverse cosine of negative 4.885 divided by 6. Now, if we type this into our calculator, inverse cosine of negative 4.885 divided by 6 comes out to be 2.5, or let's say 2.5221. Inverse cosine is defined from 0 to pi. That's what we said earlier. So the angle that it's giving us is this angle right here. All right? So from here to here, that angle is 2.5221. It's not quite pi. Pi is 3.14, right? So if we know that angle is 2.5221, let's figure out what this angle is right here. The way we get that is we do pi minus 2.5221 and that's 0.6195. And then that's what this missing piece is right here. We want to add that missing piece to pi radians. So this is 0.6195, and now we're going to add pi to it. So this angle from 0 radians to pi, and then plus that extra little piece we just figured out. So it's going to be pi plus that number, which of course is the same thing we got using sine. And then lastly, we have to talk about tangent. So with tangent, we don't have to multiply by the radius because that's already worked into when you're taking the slope of the y value divided by the x. So what I mean here is that we know that the tangent of theta is equal to the y value divided by the x value. And then if we take the inverse tangent of both sides, let's see what we get here. We get an angle, so inverse tangent of negative 3.484 divided by negative 4.885. This comes out to be 0.6195. Remember, tangent, inverse tangent, is defined from negative pi over 2 to pi over 2. So this angle that it's giving us is this answer right here. That's that little piece. We want to take that little piece and add it to pi in order to get the full angle. So the full angle here would be pi plus 0.6195, and that gives us the same answer. So we got the same answer using 3 different techniques. Which way is easier? I mean, they're both easy, they're both the same level of difficulty in my opinion. But if I were you, what I would do is I'd maybe solve it using one way, and then I would just confirm it maybe using another trig function. Let's move on to the second problem. So it looks like the angle is between negative pi over 2 and pi over 2. So it might make the most sense here to use either sine or tangent, because both of those inverses, in order to figure out the angle, is defined between negative pi over 2 and pi over 2. The only reason why tangent we don't include those values is because those are asymptotes. That's where the function was undefined. So even though we could use cosine here, I think sine and tangent are the easiest because it's going to give us an angle between negative pi over 2 and pi over 2 anyway. So with sine, we know that the radius is 2.8, so 2.8 times the sine of theta is equal to the y value, 1.8. So the sine of theta would be 1.8 divided by 2.8, and then if we take the inverse sine of both sides, let's see what this is. Inverse sine of 1.8 divided by 2.8 comes out to be 0.6982. Now just keep in mind that inverse sine gives us a value between negative pi over 2 and pi over 2. The angle that it gave us is positive, so it has to be this angle right here, which is the one we're looking at. So I would say that the angle is 0.6982. We could hopefully get the same answer by using tangent. Remember, we don't have to multiply by the radius, because if we're using the y and the x value, it's automatically factored in. So the tangent of theta would equal the y value over the x value. If we take the inverse tangent here, we get that theta is equal to, so let's see, second inverse tangent, 1.8 divided by 2.14. I'm getting 0.6993. Tangent gives you a value between negative pi over 2 and pi over 2. So because this is a positive angle, it's giving us this one. If it was negative, it would be giving you this angle, which you would just take the absolute value of. Both of these angles are exactly the same thing. The reason why they're a little bit different is because of rounding. So the system won't care if you do that. Just to make sure our notes are complete, let's figure out what it would be with cosine. So we would do 2.8 times the cosine of theta is equal to the x value, 2.14. So then we would take the inverse cosine of 2.14 divided by 2.8 to give us theta. And let's see what this is. The inverse cosine of 2.14 divided by 2.8 is 0.700. Because inverse cosine is defined from 0 to pi, this angle is right here. It's the same exact answer as the other ones. So we just confirm this answer using 3 different ways. All right, I'll keep going with this one. This is similar to the last problem, but it looks like this is multiple choice. So what's the value of theta? Well, I'm looking right at tangent first because tangent is independent of the radius. So I know that tangent of theta would equal the y value over the x value. So therefore, theta would equal the inverse tangent of 1.87 divided by 2.22. So it looks like this is the right answer. So I know that this is not true. Let's see if the other ones would be correct as well. Now let's check it with sine. We know it's sine 2.9 times the sine of theta would equal the y value 1.87. So theta would be the inverse sine of 1.87 divided by 2.9. Remember, inverse sine is defined from negative pi over 2 to pi over 2. So if we type this in, inverse sine of 1.87 divided by 2.9, I'm getting 0.700, which is exactly the same thing as what you would get with tangent. So it looks like these are correct. Cosine would be correct as well if we were to do that. So I'm just going to say that all of the answers are correct. Right. And remember, just quickly with cosine, 2.9 times the cosine of theta would be the x value. So this is why the inverse cosine of 2.22 divided by 2.9, with cosine being defined from 0 to 180, or 0 to pi, it gives you exactly the same angle as everything else. So this would be all of the above. All right, we have a couple more problems to wrap this up. So let's see, an angle has an initial ray pointing in the 3 o'clock direction and measures theta radians. The circle's radius is 2.5. So let's go ahead and set this up just like we've done all the other problems. First thing we're going to do is, let's do tangent, because that's irregardless of the radius. So the tangent of theta would be the y value divided by the x value. So therefore, the angle would be the inverse tangent of 2.16 divided by negative 1.26. I'm going to type that in here, second tangent, and I'm going to do 2.16 divided by negative 1.26. And I'm getting negative 1.0427. Remember that tangent is defined from negative pi over 2 to pi over 2. We got a negative answer, so this angle is negative 1.0427. That angle is called the reference angle. That would be the same thing as this angle. So if you want the full angle, what we would do is we would take pi radians, this whole thing is pi, and then subtract that angle. So we're going to take pi radians subtracted by 1.0427, and I'm getting that the angle is 2.0989. That's what the angle is. Okay. So let's see. I don't believe that the answer that they have here is correct for tangent, because like we said, the angle that they gave us would be this angle over here. Right? So that's a totally different angle. So I don't think this is correct. Let's try something else. Let's try sine. So I would do 2.5 times the sine of theta is equal to the y value, 2.16. So sine of theta would be 2.16 divided by 2.5. If we take the inverse, remember that sine is defined from negative pi over 2 to pi over 2 as well. So if we type that into our calculator, the inverse sine of 2.16 divided by 2.5, I'm getting 1.043, which is the same thing that we got before, but in this case, that's this angle right here. That's not the angle that we want. So in order to figure out the angle that we want, what we would do is we would take pi, the whole angle, and then subtract that little piece to get the bigger angle, just like we did in the last problem. So we're going to do theta is equal to pi minus 1.0427, and we get exactly the same thing. So I don't believe that sine works either. The answer is supposed to be this, right? But neither one of our questions give us the right answer so far. It probably makes the most sense to use cosine for this, because we know that the inverse cosine is defined from 0 to pi radians. So we'd get an answer somewhere between there, and hopefully it's going to be this angle right here. So sine doesn't work, therefore it's not all the above. So when we're figuring this out with cosine, we could do 2.5 times the cosine of theta is equal to the x value. So therefore theta would be equal to the inverse cosine of negative 1.26 divided by 2.5. And if you type that into your calculator, the inverse cosine of negative 1.26 divided by 2.5 is 2.0990. That looks like exactly what we're supposed to get, but it's just a little bit simpler. The reason why this works is because inverse cosine is defined between 0 and pi anyway. So when you type it into your calculator, you're going to get an answer between 0 and pi, which is what this question is. So I would say that this is the correct answer, this one right here. Okay, and then we have one more problem here. It says Rose is skiing along a circular ski trail that has a radius of 1.6. So let's go ahead and set this up with a picture. And we know that the radius is 1.6. Okay, and she starts at the 3 o'clock position and travels in the counterclockwise direction. So she's going in this direction. Rosa stops skiing when she is 1.508 east and 0.534 kilometers north. Okay, so that means that this point is 1.508 east and 0.534 north. How many kilometers did Rosa travel along the ski path? Well, this is asking us to figure out the length of this arc right here. Not the angle, it's actually asking us to figure out the length of the arc. So, we know that an angle in radians is defined as the arc that's divided by the number of radiuses, right? So 1 radian is the length that 1 radius would cover if you were to wrap it around the circle's circumference. So if we're looking to solve for the measure of the arc, which would be the distance here, let's just rearrange our problem and figure out theta in radians times the radius would give us the measure of the arc, which is the distance we're looking for. So the measure of the arc, let's fill in the blanks here. Well, we know that the radius is 1.6 kilometers. We just have to multiply that by the angle. All right, so we have to figure out what this angle is. We have 3 different ways to find that angle, so it doesn't really matter. I think what I'm going to use is probably cosine makes the most sense, because cosine would spit out an angle between 0 and pi radians anyway, but we could still get this using any number of ways. It looks like this wants us to do it in sine, which is okay. We could use sine too. Sine would give us an angle between negative pi over 2 and pi over 2 radians. All right, so let's figure this out. We know that the radius is 1.6. And times the sine of the y value equals 0.534. So therefore sine of theta is 0.534 divided by 1.6. And if we were to take the inverse sine of this, we get 0.534 divided by 1.6. That would be our actual angle. Sine inverse is defined from negative pi over 2 to pi over 2. So hopefully when we type this into our calculator, we're going to get an angle right here, which means we won't have to make any adjustments. So let's type in inverse sine of 0.534 divided by 1.6, and I'm getting 0.34. So that's great news. If it was a negative angle, we'd have to multiply by a negative to get a positive angle to put us in quadrant 1. But this gives us a positive answer. So what we're going to have is 1.6 radians times our angle, the inverse sine of 0.534 divided by 1.6. And let's see what answer that is. 1.6 times the inverse sine, so definitely not this one. Definitely not this one. And we're looking to do 0.534 divided by 1.6. Looks like this is the right answer.